Welcome back, smart mathematicians. Let's do question 11b. A farmer draws a rough sketch of the two adjacent fields he needs to fence. Field A is a square with a width of x, so it means this side also is x. We did this when we're doing 11b. And then field B is a rectangle in shape with a width of y. Okay, so it means if it's a rectangle, field B is a rectangle, also it means that one, this side will be x, isn't it? Because MPQS is a bigger rectangle there. The area of field A plus area of field B is 1000 units, and R is the only fence that is shared by both field A and field B. Calculate the value of x so that the minimum amount of fencing is used. Right, remember in the previous question we found y in terms of x. We said that the area of field A plus area of field B. Area of field A is said is x squared, and then field B is x times y, length times width, plus xy is equal to 1000, and then we transposed x squared, became xy is equal to 1000 minus x squared, and divided everything by x. We got that y is equal to 1000 divided by x minus x. So this is y in terms of what? In terms of x. Y is equal to 1000 divided by x minus x. After dividing here by everything by x, divide this by x, divide this by x, divide this by x. Calculate the value of x so that the minimum amount of fencing is used. So we need to find the length of the fence that is going to be used here. So it means we are looking at this distance plus this distance plus this distance plus this distance, even plus this distance nr, which is also x. Okay, so if you check, we can do this thing differently, but if you check, I'll say this is x, this is x, this is x, this is x, this is another x here, and then this is another y there. So we can add all the x's, 1, 2, 3, 4, 5 of them, and then 2y. So the fence is equal to 5x plus 2y. So now we have to derive the fence with respect to x. You have to find df dx. We have to find f in terms of what? In terms of x only. So how do we get rid of this y? Remember, we have y here in terms of x. The fence here, the length of the fence, equal to 5x plus 2, and then times, we're replacing y with 1000 over x minus x, 1000 over x minus x. And then let's distribute the 2. So it becomes f is equal to 5x plus 2000 over x minus 2x. And then f is equal to 5x minus 2x, that is 3x. 3x plus 2000 over x. Right, let's go to the next slide and use more space there. F equal to 3x plus 2000 over x. And remember, for us to be able to differentiate using rules, our terms must be in the form ax to the power n, like that, okay? So that you can say n times a, and then x to the power n minus 1 to derive. So it means we must write this one in this form. So it becomes a fence is equal to 3x plus 2000 x to the power negative 1. Now we can find df dx. So df dx, we're deriving the length of the fence with respect to x. 3x, derive 3x, we get what? We get 3 minus, because we're saying negative 1 times 2000, so it's negative 2000. And then x to the power negative 1 minus 1 is negative 2. So it means, let me just do it here. df dx is equal to 3 minus 2000 over x squared. And then it says calculate the value of x so that the minimum amount of fencing is used. So when the minimum amount of fencing is used, df dx is equal to 0. Derivative at the maximum point is equal to 0. So 0 is equal to 3 minus 2000 over x squared. And then 3 is equal to 2000 over x squared. If you transpose negative 2000 over x squared to the left hand side, it becomes positive. See, so it becomes like this. We want to find x, so you can multiply both sides by x squared. So it becomes, or you can cross multiply here, whichever method you're comfortable with. So you can put 3 over 1, then you cross multiply. Let's just do that. 3 times x squared is 3x squared. And then 2000 times 1, 2000 times 1, that's 2000. And then we have divide both sides by 3. So x squared is equal to 2000 divided by 3. Then square root both sides. Square root here and square root there. It means therefore x is equal to the square root of 2000 over 3, which is x is equal to 25,82 units.